So here we are in Unit 6, and we're going to take a look at the energy resources that are available and how we use them. As always, I'm going to kind of go fast through those essential knowledge points, but make sure that you are pausing and really taking a look at what you need to know. And here's 6.1, just looking at the differences between renewable and non-renewable resources. And so basically, non-renewable resources are any energy source non-renewable energy, okay, because there are all kinds of resources, right? But is an energy source with a finite supply. It's totally fixed. You can really not get more in your lifetime. Basically, in a human lifetime, if it can't be renewed, it's considered non renewable. And so that includes natural gas, oil, coal, and then nuclear power because of the uranium that you need to mine in order to have nuclear power. Whereas renewable energy is any energy source that can actually be renewed or non depletable, meaning that you're not really consuming it, right? Such as wind and solar, hydroelectric. Um, whereas, right, renewable resources can be considered something like biomass and biofuels. And so they're potentially renewable, but it depends on what trees you're using and how fast you're cutting them down. So now we're gonna swing into how the world actually uses their energy, or really what are the trends around the world. And if you look at this graph, you can see that the more developed countries, right, countries with a higher GDP, are actually using more energy. So the equity on which countries are using how much, more energy really depends on how developed a country is. And so if you look at Mexico, their GDP is quite low, but also their energy usage is low. And so the as people get more affluent, they tend to consume more and use more. And so that's why these more developed countries are really using a lot more energy than the underdeveloped countries, where Iceland's kind of an outlier out there. I'm not sure what's happening up there. Um, anyway, looking at what kind of energy each country is using, if you look at this graph, you can see that really that fossil fuels are most widely used. So we have coal, crude oil, and natural gas. That's the majority of the energy that's being used. And so the renewables are way up there in the tippy top, right? Really tiny little slivers. And at the bottom there, you have traditional biofuels. The traditional biofuels are more like wood and animal dung, things that mostly are used in underdeveloped countries for heating and cooking purposes. And so, because we have this large population of the world in underdeveloped countries, right, those biofuels are really, that's why we have such a large number of them on this graph. But as they become more and more developed, they're going to be using different sources of energy. And so, again, right, here is um, well, this time we're just looking at the US and what our energy consumption looks like. Oil, petroleum is really our largest sector there, mostly because of transportation. Natural gas and coal are really used for electricity. Um, and so we have this tiny little part of the energy of renewables. And so just 11% of the energy used in the US is renewable energy. And so, depending on where you are, your energy source is going to differ. So, depending on what your geographic area and your geologic um, foundation there is going to determine that. If you look out in the West, right, you have a lot of geothermal energy because there's a lot of tectonic activity where on the East Coast in the United States, we don't really have that. So we're not using geothermal energy the way that the West Coast can. Right? So the energy source that you use is what's available. Um, and so there's a difference between buying and selling certain energy sources and also just gathering it for individual or immediate needs. If it's not available and I'm in a country that doesn't have this sort of commercial setup, then I am going to use one, more biomass as opposed to fossil fuels. So another thing that really determines the kind of energy that people use is price. Um, so OPEC, the Organization of Petroleum Exporting Countries, are a collection of 13 countries that actually set the price per barrel of oil. And so they really have this monopoly on the oil market. And so what they decide to do with the price of oil really matters around the world. So if they reduce production and they raise the price of oil, that's going to affect us at the gas pump. And when that happens, people tend to change fuel sources. Um, not enough for OPEC to want to lower the prices again, but here you have a graph of when gas prices go up, so do electric vehicle prices. So people are like, oh, I'm going to buy an electric car, buy that Tesla. Or, like a Volkswagen maybe. But anyway, right when gas prices are higher, people are looking more into alternative energies. And then when the gas prices fall again, people will go back into their comfortable gasoline usage. And another um, looking at price is that natural gas has gotten really cheap, and so it's replacing coal. It's a lot cheaper um, to operate a natural gas plant, electricity plant, than to be coal burning. I mean, just the overhead of workers in a coal plant. It's a lot safer to have them working with natural gas. Also, the the need for looking at your emissions, you would have to retrofit all these coal plants, whereas if you switch to natural gas you don't have such a dirty fuel, and so you wouldn't have to put those kinds of things into play. So it would affect the price big time. Another thing that affects which energy source people actually use is the government. How the government treats different fuel sources is going to affect that. If they give subsidies to the fossil fuel industry, like here in the US, the government gives $20 billion directly to the fossil fuel industry, whereas on renewables, they don't actually give money directly necessarily, or not a lot, but most of the money that they give renewable energies companies is through tax breaks, and it's only about 6 billion. So imagine if that were flip flopped, right? If you have the money, you're going to be able to keep going with your technology. And so it, here's a table of in 2010, 2010, 2013, and 2016, um, how how much the U.S. government gave each of these industries. And so you can see that our, top three are crude oil, coal, and natural gas. Not in that particular order. I just read it in a different order. Sorry about that. Anyway, another way, right, instead of just, subsidies, are actually some sort of government incentives. So, for example, the state of Connecticut could um, give you a break on your property tax for your car if you have an electric vehicle, or priority parking at stores um, for electric vehicles. You see them all over Stanford. So, fuel types and uses, we're going to go through all the different kinds of um, fuels and how we use them. So we're looking at this biomass here, wood and peat. Um, and so wood is really just used as firewood. Um, and charcoal is actually burnt wood, so technically wood also. Um, Wood is super easy to access. You can just go down and cut down a tree, right? But it relates to deforestation. Mostly, like I said before, wood is used for heat and cooking, and it creates all kinds of air pollution, particulate matter, so soot, carbon oxides, so carbon monoxide, carbon dioxide, nitrogen oxides, um, nitric oxide and nitrogen dioxide, and sulfur oxides. So COX, NOx, and SOx. And remember that that X denotes a number. So in carbon monoxide, it would be, right, CO, imagine the one, or CO2. So depending on what number you're looking at. So moving on. Peat is partially decayed organic matter. So it's like the very, very first step in the formation of other fossil fuels, really coal. But we use it before it's completely there. And it's harvested from bogs. And bogs are really efficient carbon sinks. Um, so when we take peat out of a bog, we're actually removing a lot of carbon and the ability for the bog to take up carbon. Um, and bogs are not everywhere. I mean, when's the last time you saw a bog in Stanford? But they're harvested. I'm sorry. um, but bogs, right, are specific to certain locations. They use this a lot in Ireland. There's a lot of bogs there. But it's used for heat and electricity. So whether you're heating your home or burning it to generate electricity, which we'll talk about in a moment. Um, Obviously, you can see you're digging these massive trenches through the bogs, so you have habitat destruction. And then because it's so like not processed into a fossil fuel yet, the carbon dioxide emissions are really, really, really high, and you need a lot of it to make the same amount of energy as some other fossil fuel. So it creates low BTUs or British thermal units, and we'll talk about that more too. All right, so coal is our next one, right? Coal is super dirty, um, very efficient. So it has more British thermal units than any other fuel source. It burns very, very hot. And what does that mean? That means that a BTU is the amount of heat generated to raise 1 pound of water 1 degree Fahrenheit. Why British thermal units? I don't know. But anyway, you can see that coal is super, super efficient. It burns really, really hot. And it's really widely available. It's all over the place. And it's relatively inexpensive because there are a lot of technologies that are already in place for it. Of course, we know from our mining unit that it creates quite a bit of habitat destruction, um, lots of air pollution. Like I said, it's super dirty. Um, Particulate matter, COX, NOx, and SOx, and methane. Also, actually subsurface mining, one of the biggest threats to coal mine workers is that when you unearth a coal seam, there a lot of methane gets emitted, and so it really needs to be checked for before you send workers down into the mine, and it's explosive. Um, and then, of course, coal. There are a lot of health concerns. Black lung is a real thing, and so there's a lot of overhead when it comes to health care and insurance when you work with coal. And so there are really, right, we talked about peat. It's not a coal, but I love this picture. It says so much on the left here. But basically, there are three types of coal there's lignite, bituminous, and anthracite. Anthracite's like the good stuff, it's low sulfur and burns really hot. So really nice and highly desirable. Well, nice as coal can be, I guess. But it's really limited and hard to get to. And so, bituminous coal is really the coal that we use the most, at least here in the United States. And it burns really hot, but it also has a really high sulfur content. And where lignite, it has a low sulfur content, but it burns pretty, uh, or not, it's not efficient when it comes to heat generation. So our next fossil fuel is natural gas, um, mostly methane is what we use as natural gas, but it can also include butane, propane, right? All of these anes. Um, and it is a much cleaner burning fuel than coal or oil for that matter. There's relatively large reserves, which is why natural gas is like the big thing right now. When it combusts, it actually combusts fairly cleanly. Like I said, it doesn't have that particulate matter that the other fossil fuels have. So if you look at carbon, right, if you look at methane, right, we're oxidizing it, meaning that we're combusting it, always adding oxygen into the mix when you combust something. And really the byproducts are water, carbon dioxide, and energy. Um, so as we're extracting it, the excess gets burned off and wasted. We just don't have storage and transport for the amount of natural gas that we're getting out. Another thing that can happen is that as we're actually extracting the methane can leak into the troposphere, and methane is one of the most powerful greenhouse gases there is. We talk about carbon dioxide a lot, and we haven't done climate change yet. I get that. But the reason why we talk about carbon dioxide is because it's so prevalent, there's so much of it. But methane is much more powerful as a greenhouse gas. And then when we extract it, but then when we transport it as a liquid or compressed natural gas. So either we bring it down to temperature or we squeeze it. Crude oil, right? There are lots of different forms of crude oil. There's conventional crude oil. You think about like Texas and pumping it out of the ground. Of course, there's offshore drilling, like in the Gulf of Mexico. Um, and so this is just liquid petroleum. And then usually those pockets of crude oil also have a lot of natural gas there as well. But there's some unconventional ways to get oil out of the ground. One of them being tar sands. So tar sands are a mixture of sand, clay, water, and bitumen. Yes, it's similar to bituminous. So good for you for, figuring that one out. Very related, fossil fuel and all. But bitumen um, is like a tarry substance. It's very high viscosity. Sorry. We can actually take that and refine it into crude oil. But the crude oil that it's refined into is actually very um, high in sulfur, and it has a relatively low efficiency. Um, but it's there. Another one is oil shale. A lot of times, you take this oil shale and use it as almost like a coal, like you just burn it directly. But you can also extract the carrigan out of the rock and refine it into other petroleum products. Again, it's pretty low efficiency. It's just you have to put in a lot of effort to not get that much out of it. Why do we even use so much crude oil? Well, it's stable. It's not explosive like natural gas. Um, it burns high BTUs, but it doesn't pollute as much as coal. Um, there are technological and financial systems in place, so it's relatively cheaper than renewables because that stuff's already in place, and it's convenient because it's around. But like I said before, right? You have habitat destruction and alteration when it comes to extracting it, spills and leaks through transporting it, and then you know it's cleaner than coal, but it's still not clean, right? You still have particulate matter, and then those cox, knocks, and socks. And so once we have that crude oil, we actually refine it to get lots of different products. So basically, what we do is we put the crude oil in, we heat it up, and then we pull off those products at different boiling points. And so, um, right, you have like those gases, so we can actually get natural gas from the crude oil. But then you have gasoline, which is actually a pretty low boiling point. Um, Jet fuel, heating oil, diesel oil, um, right? Grease and wax, so like petroleum jelly, right? And then asphalt. All of these things are coming from petroleum. What's not in this little diagram here is also any kind of plastic. Plastics are petroleum products. Um, and so, we basically distill at different temperatures to get the product that we want. Now, cogeneration is special because we can use any of those fuel sources and we can actually use it for two different things. So we call it cogeneration because not only are we generating electricity, but we're also using that heat to heat spaces. So let's say, like, right, you have a natural gas plant. And so, right, that natural gas plant is generating electricity, but it's also generating hot water because that's how we generate the electricity. And um, we can use that hot water to heat a building. So, all of these are at different places on Earth, right? Depending on, like I said before, depending on where you are on Earth, that's going to depend on the type of energy source that you use. And basically, it all depends on your geologic history. What is that bedrock underneath? Are we looking at sedimentary rock, right? What was happening in that place, in where you are underneath your feet millions and millions of years ago? Because that's how long it takes to make fossil fuels. So if you look at the coal, right, coal deposits are going to be different than natural gas deposits, which is going to be different than oil deposits. Although oil and natural gas are pretty related, so maybe I should say more like, right, that shale, like the shale, actually, as opposed to like liquid conventional crude oil. Right, so different countries have different distributions of these resources because they have different geologic histories. And so that when we're talking about long, long time ago, that's important. So just really an overview of fossil fuel, some more about like getting more into the depth of how fossil fuels actually work for us. Um, right? We are combusting fossil fuels. So we are adding oxygen to a organic compound. And in this example, it's methane, but it could be, the carbon source of coal or oil, whatever it may be. We're adding oxygen, we're getting carbon dioxide and water out of it. But this releases energy through these chemical reactions. I'll add in there that an incomplete combustion is where you get that soot and carbon monoxide. So, when you have incomplete combustion, it doesn't burn as readily and as cleanly. But right, these reactions are creating energy, and that energy is generating heat. We use that heat to heat the water, and that water turns into steam, and the steam turns a turbine, and the turbine generates electricity through a bunch of right. There's this spinning wire through magnets, and you have electricity that then gets brought out to a transformer into something that we can use. So each of these fossil fuels that we can use in this way, right, has to be extracted. And so, like I said before, right, we extract coal through mining, and we've gone over that extensively. And there's both surface and subsurface mining. And then it's shipped via conveyor belt, train, ship, right? Barge, pipeline. If it's made into some sort of slurry that can be used as like almost like an oil. We don't do that in the U.S., but you can actually liquidize coal for for burning. And coal is really 38% of the global electricity production. So, quite a bit. When we're extracting oil, there are all different kinds of recovery that we can do. Obviously, the most obvious is primary oil recovery, where we're actually drilling a well and pumping it out, and that flows by gravity into a well. So we're just pumping oil out of the ground. Secondary and tertiary are a little more tough because it takes more effort. We have to actually inject water to force the oil out, and then tertiary is injecting steam to force the oil out. And so the more you starting to put into it to get that oil out, obviously the more expensive it's going to become and maybe not worthwhile financially. When it comes to oil, once it's extracted, we got to transport it. And we can do that through pipeline and through tanker mostly. And with pipelines come all kinds of issues. I'm sure you're familiar, or if you're not, you should look it up. There are all kinds of land issues in the United States going through Native American lands for to build pipelines, and they don't want it for many reasons. Pipelines can spill and contaminate water supply, which we'll talk about more in water pollution. Um, Pipelines fragment the land, so we have habitat fragmentation, and of course habitat destruction, just through the actual building of it and the roads that we need for access. And then if you ship it in a tanker, you can end up with oil spills, which we'll talk about again more when we talk about water pollution. Um, Natural gas extraction often occurs in the same areas as oil. Like I said, they're usually found together. Um, so storage and transport from the drilling rig is actually a huge problem. Like I said, they burn off natural gas as a waste product because they can't store it as well. And so you can pipe it if you compress it and or lower the temperature to make it into liquidized natural gas. So, of course, there's traditional pumping of natural gas, but there's also something called fracking, scientifically known as hydraulic fracturing. And basically, you're drilling wells into rock and using pressure to crack the rock to release the oil or gas. And so you are putting a like water, but the problem is it's not just water, it's other stuff too, to actually perforate that rock and get the oil and gas out. And the consequences of that are really unknown at this point. Um, so you're fracturing the earth, in the bedrock and down underneath your aquifer. So, there could be consequences there. I don't, maybe it causes earthquakes, subsidence where, where the earth is actually sinking. Um, the chemicals that they use to do this could contaminate the groundwater. And the thing is about that mixture of chemicals is that there's a lack of regulation on it. It's a proprietary blend, right? They actually don't have to disclose what they're putting into the ground. Um, and so most of it is water, but there are all these additives to make sure that the fractures stay open and also to prevent corrosion in the pipes of the wells. And so you can see there's all kinds of stuff, and none of it's very specific. And so, it's very possible for this hydraulic fracturing solution to get into the groundwater and contaminate it.